Okay, a little two-part lesson of equivalent expressions and then coming up with equations here. So this is kind of the last part of the course before we get into the word problems, or not course, the exponents question, exponentials unit, unit 3. So equivalent expressions, again, if you, a little life lesson, if you scribble, people can't tell if you can't spell. So here we have also, if you scribble your numbers, no one can understand what you're doing. Anyway, I have 9 to the x. And I want to rewrite this a couple of different ways. So I have 9 to the x, and I want to rewrite this a couple of ways. So what I'm going to do is rewrite the base here as a different form of a power. So 9 can be rewritten as 3 squared. Okay, so over here I have 3 squared. So I can rewrite 9 to the x. I can replace the 9 with 3 squared. So I have 3 squared all to the x. Now it's a power of a power scenario here. So that's 3. 2 times 2 is 2x. And so 9 to the x is equal to 3 to the 2x. Now, the other thing you can always do is you can square, if you're trying to figure out another way to represent a number like 9, and usually you ask 2. The other thing, 2 ways to do it. The other thing you do is just to square the number. So 9 times 9 is 81. And then you can say, okay, 9 is equal to the root of 81, or the half the power of 81. And that's what I've done here. Okay. So you can always do that, and that comes up later. Some of the numbers get ugly, but it does work. So I can come back and say that 9 is 81 to the half. So 9 to the x is 81 to the half to the x. So that's 81 to the half x. Now there's other ways to do this also, but there's nothing wrong with that. So if I go to 27, for example, 27 is 3 times 3 times 3, or 3 cubed. So 27 to the 2x is 3 cubed to the 27 and to the 2x. Now how did I know this? Well, it just kind of trial and error, right? Remember how you gotta get used to these numbers. 27 is 3 times 3 times 3. So we look at the powers of 2, the powers of 3, the powers of 5. Those are the ones we usually deal with. So that is a power of a power again. So I have 2 times 2x times 3 is 6x. So I'm left with something like that. Now, if I wanted a second expression, I could find out what 27 squared is and figure out what that is, and then put that to the power of a half, and that would be, and then shove that into here, and I would get the same thing. But let's do one more. So I mean, you can always do that. Let's do one where it gets a little tricky here. 5 can be expressed as 5 squared. Or 25 can be expressed as 5 squared. So 5 squared replaces 25, and you go 5 squared to the power of 5x minus 3. So I just, where I had a 25, I put a 5 squared. And that turns into, you're going to multiply this times this. That's going to be 10x minus 6, and there you go. Okay, so that's the same as that. Any other tricks? If you find other ways to find equivalent expressions, that's great. Like if you know that, for example, here, another thing you could do is say, okay, 27, that has to go with 9. So I could say 27 is the same as 9. If I get the root of 9, that gets me back to 3. And then if I cube it, I get back to 27. So that's another way to write that. You can do stuff like that, but if you're not up for it, then just take the root of this number and then of the base, and do it once, and then take the square of it and do it the second time. Okay, so hopefully that makes sense. I'm not sure if it did. A b to the x plus asymptote. So what's this all about? That is, here's an equation, or here's a graph, sorry. And now we're going to come up with a equation for the line. So now I have this line here, and the line has an asymptote of 1. It goes to this point at 3. It goes up to so 0, 3. The next point is 1, 7. And the third point on this line is this, 2, 18. Okay, but I didn't write them here because I didn't have too much stuff here. Because what you have to do is, first thing you want to do is remove the vertical transformation. So the way it works is this. My equation of my line is going to be like this: a b to the x. But, and I've always said that's the case. That's what we have for exponential functions. But you may have been moved up or down. So a b to the x plus your asymptote. So what's the asymptote here? 1. Okay, so that's going to be, when I work here to find out my equation, I'm going to know that I'm going a b to the x plus 1. So now what you do, the first thing you do is remove the vertical transformation, or remove the asymptote. So I'm going to move this whole thing down one spot to figure out what my points are going to be. Make sure this is right. No, I'm sorry. This point was 19. Okay, that makes more sense. That point is 19. Okay, that's just the point from the note. So everything's going to come down 1. So this is now at 2. This now is at 6. Okay, and this guy now is at 18 here. So my points look like this. So what are my points? So now the asymptotes come down also. So my points are 0, 2, 1, 6, and then 2, 18. So now I need A and B. A is, remember, A is my intercept. So A is going to be this. A is going to be 2. So there's A. And then B, to find B, I shouldn't have done that. To find B, what you're going to do is find the ratio of the first differences. So that goes up 4, that goes up 12. And how do you go from 4 to 12? As a ratio, it's times 3. So there's my B. That's it. That's all you have to do. A is this, B is this, and you're done. So this is Y is equal to A2 times 3x all plus 1. Now there are many different equations to this, for this, but that's one of them. Okay, so there are other ones here also that that you can come up with, or don't. So let's see if this is right. First of all, let's go to Desmo. So that's 2 times 3 to the x plus 1. See if I can remember that. I'm getting old. 2 times 3x plus 1. I could also pause. No. 2 times, what did I say? Times 3 to the power over here, x plus 2. I'm kidding. Plus 1. Is that right? I don't trust myself. 2 times 3x plus 1, 2 times 3x plus 1. What's that look like? Does that look like this? Is that what I had originally? Well, my original points were 0, 3, and my next one was what? 1, 7, I said, right? So at 1, I'm at 7. There we go. And the last one was what? 2, 18, 219, 219, 219, 219. So 219 is right there. So if I zoom out, which I'll do right now, that was my original graph and what I end up doing. So that is the equation for this guy right here. Now I got rid of the asymptote and found out what that was, moved it down, get rid of the vertical translation to help me work through that. Okay, so that's that. Go over that one again. So again, get rid of the asymptote, that goes here. Then you get the new points. You shift the points down or up depending on what the asymptote is. Okay, what the change is. If I moved up 1, I want to get to 0. And the reason I get rid of the asymptote, I'm sorry, I should have said this, is AB to the x, you're going to have an asymptote of 0, right, at all times. Even if it's flipped, it's always 0. So you want to go back and work backwards and get rid of the asymptote because it's built into the points in blue, and move them back to the points in red. Once you get rid of the asymptote, then you know your A, find your A, and then you find your B. Okay, hope that makes sense. And that's about it. And then all we have is word problems, and the unit's over.